Good morning, my YouTube viewers. In this particular video, we're going to carry out an A/B test, and we're going to check a new treatment for diabetes. And so we're going to carry out an A/B test to see which treatment is better, if the standard treatment is better or if the new drug is better. So we're going to write a program in Python to carry out this A/B test. And before we do that, what we're going to do is we're going to import the libraries that we're going to need to execute the program. So we're going to import NumPy as NP, which is a numeric library that also creates NumPy arrays. We're going to import Pandas as PD, which is a data processing library, which also creates data frames and series. We're going to import matplotlib.pyplot as PLT, which is a visualization library. And from scipy.stats, we're going to import ttest_ind. So scipy is Python's scientific library, and stats is a statistical module within scipy. And ttest_ind is the test that we're going to perform. So the first thing we do after we have imported our libraries is we want to simulate the data. And the first thing that we do when we simulate the data is to import, is to set the seed. And the reason why you set the seed is because every time you run the program, you want to initialize the variables to the same values. And you do that by typing np.random.seed and any number you want between the brackets. So, and then we're going to define the variable n participants equals 100. So that means there's 100 participants or 100 people with diabetes. So now we're going to simulate blood sugar reductions in milligrams per deciliter. So we have a control group, which is a placebo, so you're going to do nothing at all. So the control group is equals np.random.normal, brackets, log equals 10, comma, scale equals 3, comma, size equals n participants, and then it's going to be floor 2. So basically, log is your mean, so your mean is 10, your standard deviation is 3, and the n participants log 2 is 50. So it's going to be 50 participants in the control group who get a placebo. And then now they're going to test the new drug. So the treatment group equals np.random.normal, brackets, log 15, comma, scale 4, comma, size participants, floor 2. So your mean is 15, your standard deviation is 4, and the sample size is 50. So now we're going to take this data and we're going to convert it into a data frame using Pandas. Data equals pd.dataframe, brackets, curly brackets. The first group is group control times n participants, floor 2, plus treatment times n participants, floor 2. And then the blood sugar reduction equals np.concatenate control group, comma, treatment group. So now we're going to get our summary statistics. So summary equals data.group by, brackets, group, square brackets, blood sugar reduction, .agg, that means aggregate, of the brackets and the square brackets, mean and STD, and you're going to reset your index. So that's your summary. So now we're going to perform an independent t-test. An independent t-test is when the two samples are not related. That is when you use the independent t-test. So t-stat, comma, p-value equals t-test_ind, brackets, control group, comma, treatment group. So now we're going to print the results. We're going to print the summary statistics, and then we're going to print the test results, t-test results. So we're going to print the t-test and the p-value. And your p-value is your probability. So your summary statistics is the control group mean is 9.3 and standard deviation is 2.8, and the treatment group mean is 15 and the standard deviation is 3.4. The test statistic is negative 9.07 and your p-value is 0. And since your p-value is less than 0.05, it means you have to reject the null hypothesis and accept the alternate hypothesis. So the null hypothesis is that there's no significant difference between the two groups. And the alternate hypothesis is there is a significant difference between the two groups. So we'll go back to the code where you see if p-value is less than 0.05, you print the result is statistically significant difference between the two groups. So it has rejected the null hypothesis in favor of the alternate hypothesis. So now what we're going to do is we're going to create a bar chart of our data. So plt.figure brackets fig size equals 6, 4. Mean values equal summary mean, STD values equal summary STD, and groups equal summary group. So we're going to make a bar chart now. plt.bar brackets groups, mean values, YERR equals STD values, cap size equals 5, color equals blue, orange, alpha equals 0.7. So now we're going to annotate the chart. So the title is A/B test effectiveness of new drug versus placebo. And then the X label is the group. The Y label is the mean blood sugar reduction in milligrams per deciliter. And the plt.grid brackets axis equals Y, line style equals dash, alpha equals 0.7. So we're going to annotate the means on the bars, and so we're going to insert some code. So we're going to put the values on top of the bars, and then plt.type layout and plt.show. And so now this is the chart that we have created. And it says A/B effectiveness of new drug versus placebo. So you've got your control group, which is the placebo, and then you've got your variant group, which is the treatment. And it says mean blood sugar reduction. So the placebo, I don't think it's going to have a reduction at all. They said it was a reduction in 10. But I personally have diabetes, and I have to take 3 drugs. And I think they'd have to give you something because it's very dangerous to allow somebody who has diabetes not to take a drug, because diabetes is a very insidious disease. And so maybe they're giving them another drug in addition to the main drug, which will probably be metformin. And so the placebo in addition to metformin would be like 9.3 reduction in blood sugar. But when they give you this new drug, it would be 15.1. So it would be close to 6 points greater difference in the reduction in blood sugar, which is good because it's dangerous. I mean, I personally have diabetes. It's a very insidious disease. I personally take 3 drugs, and I don't know what's going to happen. I do my best. So this is a good test if you're working in the medical field, if you're working in health. It's a good test to see what the decrease in blood sugar is, so you can determine whether you can give the patient the placebo or the treatment. But it looks like in this particular A/B test, it looks like that you would give the patient the treatment and not the placebo. So that's it for this video. The next video, we're going to cover some more statistical subjects. So I hope you decide to watch the next video.